Hi everyone, welcome back to our channel. Today we are going to discuss about the interrelationships between impulse signal, step signal as well as the ramp signal. This is very important when you solve the competitive exams. So first signal we are going to define it as a delta of t, where delta of t is nothing but impulse signal, and this is d by dt of step signal. It is defined. Okay, so this is the impulse signal. Next signal is nothing but step signal. Already I had done a video in the previous class about different types of test signal. You can watch that video. And now step signal I'm defining with the name u of t, and it maintains a magnitude of 1 for t greater than or equal to 0. And next one I have an ramp signal. This ramp signal is defined with an letter r of t, and it maintains a value of t for t greater than equal to 0, and this is 0 for t less than 0, and this is also 0 for t less than 0, and this I can define it as 1 for a period t is equal to 0. So how this impulse signal seems to be is, this is t, and this is generally delta of t, and this is t, and this is step signal u of t, and this is x-axis is t, and y-axis you are going to have r of t. Now the signal seems to be like this. Okay, I'm drawing the signal. It maintains a magnitude of 1. Okay, so it has a magnitude of 1. Then this signal is called unit impulse signal, and here the step will be like this to what I'm showing here. So these type of signals are called as unit step signals, and here this ramp is like this, and it maintains a slope is equal to 1. So this red color line what I have been drawn are nothing but the signals. Okay, so this is the signal, and t greater than or equal to 0. So this is at t equal to 0, and this is t greater than 0. This is t less than 0. This is signal is available only at t equal to 0. When t is greater than 0 or t is less than 0, the signal is not available. Here also at t equal to 0, and this is the signal is available only when t greater than 0, and t less than 0 the signal is not available. This is the overall view of the signals. So how to get impulse from step 2 RAM. So before going to this, let's try to see the Laplace of this value. Okay, so Laplace of delta of t, the Laplace of a step signal, we are going to get it as 1. Already the derivation is done in the previous lecture video 27. You can watch from there. So Laplace of step signal, so Laplace of constant is 1. We are going to get it as 1 by s, and the Laplace of ramp signal r of t, you are going to get it as a 1 by s square. Okay, so these three are the Laplace transformations of the given standard test signal. How to get one signal from the another. Okay, so I can write down this is impulse. So this impulse has to be integrated. Integration of impulse is equal to step signal. Okay, and again this step signal we are going to integrate, we are going to get the ramp signal. So I can write a relation like this. So impulse is there, integral of impulse. Okay, when you perform integration of impulse you are going to get the step signal. So the integration of step signal you are going to get the ramp signal. Okay, so integration of impulse, you are going to get step signal. So integration of impulse is step, and integration of step you are going to get a ramp signal. Okay, so this is very very important. So in order to remember, I can say you one logic, the sequence of remembering ISRO. You already know that ISRO, ISRO. I S R ISRO already you know this. So this is the sequence of remembering. So integral of impulse is step. Integral of step is ramp. Okay. So this is what the interrelation between one signal and reverse you can see here. So here you have an ramp signal and here you have an step signal and here you have an impulse signal. What is the relationship between these three signals is very important. Okay, so here if you differentiate ramp signal, then you are going to get step signal. Differentiation of step signal, you are going to get impulse signal. Okay, that's what I had written. Differential of step. Differential of step is nothing but which signal? Impulse signal. Okay, so like this, differentiation of, I mean, integration, differentiation, or in reverse. Okay, that's what happening here. So integral of impulse is step, integral of step is ramp, differentiation of ramp is step, and differentiation of step is impulse signal. This is how to define three different signals and interrelationship between. If you remember this formula, then automatically the many problems you can solve in gate. We'll try to do that methodology also, how to solve multiple signals in differential form as well as in integral form. Hope you are able to understand the interrelationship between impulse, step, and ramp signal. Okay, so differentiation of ramp is step, differentiation of step is impulse. This is what the technique behind the application. So hope if you understand my explanation is good, please give one strong like to the video and please share with your friends, those who are studying this subject, those who need this subject. And still if you have any doubts, you can comment. I can answer your comments and you can clear your doubts. And if you're watching the channel for the first time, subscribe to the channel with the name KV Tulasiram. Kindly support this sort of free channels for the development of students and faculty. Thank you for watching the channel. We'll visit in the next video. Yours Ram.